I love working with exponents. I don't know, call me weird. I'm sure you are, but this is fun for me. The more complicated, the better. I really enjoy this stuff. We're getting into some real um, abstract thinking now, some real algebra here. So let me lay out these properties for you that we're going to use today. Three properties we're going to use today. X times a, or x to the a power times x to the b power is x to the a plus b power. X to the a power divided by x to the b power is x to the a minus b power. And lastly, x to the a power raised to the b power is x to the a times b power. Okay, and if we were doing a traditional lesson in class right now and I just taught you this, there'd be 4 or 5 hands shooting up in the air asking me to explain further what the heck I'm talking about here. But the luxury you have at home is that I can just tell you. I'm going to explain it, okay? Take your time. Just look at them. We'll refer back to them again. But basically, this is saying that when you multiply numbers with the same base, x and x, those are called the base, you add the exponents. When you divide numbers with the same base, you subtract their exponents. And when you raise a power, this is called a power, to another power, then you multiply the exponents. We're going to use that a few times here. All right, so we're going to find these missing exponents. We're going to fill in these boxes here. X to the 5th times x squared is x to the 7th. 5 plus 2 is 7. And let me show you why here. There's x to the 5th on the left. There's x to the 2nd. You have 1, 2, 3, 4, 5, 6, 7 x's. That's x to the 7th power. But you don't need to list these out every single time. I would not do that. 5 plus 2 is 7. All right, next one. X to the 5th divided by x squared. If you look at that property on the previous slide, maybe you'll see that this is going to be 3. 5 minus 2 is 3. When we're dividing numbers of the same base, you subtract exponents. And here's how that looks. On the top, we've got x to the 5th. On the bottom, we've got x squared. Notice some of the x's cancel out, and you're just left with x cubed. But again, we don't want to show all this work every single time. We just want to subtract and be done with it. Lastly, x squared raised to the 3rd power, that's going to be 6 because 2 times 3 is 6. When you're raising a power to another power, you multiply the exponents. Here's x squared, here's x squared, here's x squared. So this is x squared cubed. Notice we have 6 x's. Okay, so that's why the rules work. And knowing these properties can actually help us when we're working with numbers as well. Don't do 2 cubed and 2 squared and then multiply them like order of operations says. 8 times 4 should be 32. Instead, we can just call this 2 to the 5th power, and 2 to the 5th power is 32. Okay, down here on this one, don't do 2 to the 5th power is 32, and 2 squared is 4, and 32 divided by 4 is 8. Instead, let's just do 5 minus 2 is 3, so this is 2 cubed, and 2 cubed is 8. Keeps everything a little bit smaller. And on this one, don't do 32 times 5 is 32, and then 32 squared is gosh knows what. Instead, let's do 5 times 2 is 10, so we have 2 to the 10th power, which is 1024. Okay, so we want to write them as powers first and then do the indicated operation, which is going to get us the same answer as following order of operations, which is to do exponents first and then multiply, or exponents first and then divide. Same difference. Could be faster. And let's write each expression as a power of 10. So in other words, we're not going to fully evaluate this expression. We're just going to leave it as a power with a base 10. Okay, so 10 to the 6th times 10 cubed would just be 10 to the 9th. Okay, and 10 to the 6th divided by 10 squared would just be 10 to the fourth, or 10 to the fourth power. Okay, and that's it. So we've got three very basic properties here that when you're adding exponents or multiplying exponents to the same base, you add their powers. When you're dividing exponents with the same base, you subtract their powers. And when you're raising a power to another power, you multiply their powers. Okay, that's it for today. See you soon.